Hello, hello, and welcome back. In this video, we are talking about cylinders. So these are surfaces in 3 dimensions, cylinders, and they're not perhaps quite what you think of as a cylinder. I think for many of you, when I say cylinder, you're going to imagine a circle, like a cross-section of a circle, and then sort of extruded along an axis. So either going up or down, left or right, or front to back. That's maybe what you're imagining is just a circle extruded along an axis. Really, a cylinder is it's a surface that can that's parallel to a line in the same sense that sort of the cylinder you're picturing is. But the way I like to think about it is that if you take traces that are parallel to one of the coordinate axes, they remain unchanged no matter how you change that quantity, which trace you're looking at, as long as it's all along one axis. Another way to think about it is it's an equation in 3 dimensions involving x, y, and z where one of the variables is missing. Right, so here I'm talking about a cylinder. Consider the graph in 3 dimensions of the equation y equals x squared. Now in 2 dimensions, we know what this looks like. Maybe I'll draw that really quickly here. I'm just going to freehand the axes, so pardon me if it's a little bit rough. Here's x and y, and then y equals x squared. Maybe this is 1, 1, and maybe I'll even do 2, 1, 2, 3, 4, just to kind of get a little bit more accurate of a drawing. So 1, 1 will be on there, negative 1, 1 will be on there, and then 2, 4 will be on there, and negative 2, 4 will be on there. So right, so here's our parabola. Again, kind of rough, but I have the key features in there. And so it's going to look like this. So when I look at my traces that are parallel to the xy plane, and remember this is going to be kind of the floor when we're looking at in 3 dimensions, what I'm going to get are parabolas. So one thing I do before we start actually graphing this thing is I'm going to draw another one, but I'm going to draw it in, you know what, actually let's just jump to the 3 dimensions. Let's just jump to 3 dimensions. So remember, this is now my x-axis. This is my y-axis, and this is my z-axis. And we're trying to graph the equation y equals x squared. So I'm going to draw some ticks in here. Let's go 1, 2, 3, 4. Probably won't use the fourth one. 1, 2, 3, 4. And I'll draw some on the y-axis. So how about 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll go all the way up to 10. So what I'm going to start with here, remember, all of the traces that are parallel to the xy plane, so these traces of these planes coming like this, are all going to look like y equals x squared. So I'm going to start with the xy trace, just the one sort of on the floor here, and I'm just going to graph the parabola y equals x squared. So when x is equal to 1, one way I can help myself just be a little bit more tidy with this and make it look a little bit better is I'm going to make sure that when I come off the y-axis, I'm actually parallel to the x-axis. Let's go, this is good enough. So when x is equal to 1, y is equal to 1. And so I'm going to draw a line here at y equal 1. And then I know when x is 2, y is going to be equal to 4. And so I'm going to draw that one here, y equal 4. I'll draw the points later on. I just want to make sure I actually have these like lined up properly. And then when x is 3 or negative 3, I get y equal to 9, and so I'm going to draw another line here. And now I can plot some points. So 1, 1, negative 1, 1. It's here. Let's see, 2, 4. So that's going to be right here. Negative 2, 4. That's right here. And then let's see, 3 and 9. So I already drew my line here at 9. I knew I was going to do this. And there we go. And now I'll draw the parabola. So sort of connect the dots, but, you know, parabolically. As best you can. Again, I am no artist. That's other members of my family were artists. I could never get the hang of actually drawing things. I like to think I'm creative, but I can't really draw. Okay, so there is the XY trace. That's from setting z equal to 0. But if I set z equal to any constant, right, set z equal to any constant, say z naught, I get y equals x squared. So every single trace parallel to this one also looks like this parabola. So what I can do is I can just sort of lift this parabola up. So I'm going to maybe draw one up here. It doesn't really matter what this z value is because it's going to look the same. So I'm just going to draw a couple of z values here. And then I'm going to redraw this parabola, but at those levels. So I could be a little bit more particular about this, but I'm going to just kind of freehand it. I just want to copy this figure, but up. Let's see. There it is up higher. All right, so there it is at the next level. And then I can draw one down below as well. And then this looks a little bit sloppy, right? So what I'm going to do is, to help us visualize this a little better, is I'm going to draw vertical lines. And this just kind of illustrates the fact that we're really drawing a surface and not just a series of lines. So hopefully you can kind of start to get this picture. These lines back here on the back side of it, I'm going to draw with dots because we can't see them. There's one. There's one. There's one. So does that kind of look a little bit better to you? Can you visualize it now? Parabolas, 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 sort of going upward. One way to think about this, how I think about it, is it's a parabola in the xy plane that's been extruded sort of upward infinitely and downward infinitely, right? This thing does keep going. It doesn't stop at any point, and it just keeps on going up. Parabolas the whole way. Let's see, do I have something in the... Let's go back to this for a second. Right, so here is the curve y equals x squared in the xy plane. There's that one. And I can turn on, I can say cylinder. This is one of our e-text examples. There's the figure that we just drew. There's those parallel lines I was talking about, and there's our traces. So it's good form to draw like 3 traces and then connect them with parallel lines like we did. So I like this this interactive figure because we can also examine at the same, like, what if I changed the equation a little bit? What about instead of y equals x squared, I picked y equals z squared? What would it look like then? Can you imagine? I'm going to turn off the cylinder. So imagine, what's the curve y equals z squared look like? Y equals z squared, that means x, if I set x equal to 0, I get y equals z squared. X equals 0 corresponds to the yz plane. And so what we're talking about is the curve y equals z squared in the yz plane. So this one. And then I'm going to extrude that along the x-axis. So I'm going to turn on the cylinder here. Imagine it extruded. There it is. So in this case, we would have drawn 3 copies of this curve y equals z squared. And then we would have connected them with lines that were parallel to the x-axis. Notice how all of these lines are parallel to the x-axis. So this is what defines a cylinder, is that the surface itself is parallel to one of the axes. In general, parallel to a line, so we could have like sort of a slanted cylinder. That's fine too. I'm not going to kind of challenge you with that too much. We're not going to worry about cylinders that aren't parallel to one of the coordinate axes. We're just going to, make it a little bit nicer. Okay, that's it for this video. In the next video, we are going to examine another cylinder, and we're going to graph that and play around a little bit more. I'll see you there.